In this video, I'm going to look at bringing some weather data that I got, I believe, years ago from the Weather Underground, wonderground.com. But I put an Excel spreadsheet on my website somewhere. I'm going to bring in that Excel spreadsheet and then use the column of the data, the high temperatures. And this is, so here is that data. So this is the August temperatures from back in 2015. So I'm going to read that data in. And these calculations I've done in the meantime, they're not actually over here in this Excel file. Okay, so I'm going to bring in those data and then use Mathematica or Wolfram Cloud to calculate some like basic statistical quantities based on this data. Okay, so first I wanted to see what was in the data. And I've done some videos recently where I read a CSV file, but an Excel spreadsheet we know can have. This one doesn't have multiple sheets, but in general, an Excel file can have multiple sheets. And so I wanted to read in the fields. And I'm going to cheat just sort of like, okay, I know them. They're the date, the high, the low. But I wanted to bring, without opening the Excel, I wanted to sort of peek at the fields. And I can do that. So I'm using import to bring in the field. Here is my URL for that Excel file. And then for the CSV, this argument had 3 parts, but here it has 4 because concept of a sheet or different sheets within CSV. It's a flat text file. So there's an extra parameter here because of that Excel supports sheets. So this is the data that I always just see them put data here. I believe this one is referring to the sheet, which I'll first start out with all, and then later I'll just stick to the one to be the one sheet that there is. This third thing here is the row. So I'm just grabbing the first row, all the columns. So I'm grabbing data from all of the sheets, or there is just one sheet, so this could just as well be a one. One row, all the columns, and there it is. Now, because I said all here, it's giving me sort of a list of lists, so that's why the double. So if I enter that there, if I wanted to somehow work with these, I just wanted to see them. I don't really want to work with them in any way. But I think if I made this a 1 instead, then this would be a simpler list rather than 1 set of curly brackets rather than 2. Let's test that. And there we go. Okay, so now I want to bring in the data. So I'm going to import it again. And that time I was just importing it with just 1 row to get these headers. Now I'm going to bring it in. And again, I wanted it to be the simpler list. So I said sheet 1. This was, I only wanted the high temperature, so I wanted the second column. And then I know that the first row is headers, and there are, I know that this happened to be August, and there are 31 days in August, so I'm going from 2 to 32. And that just saves me a little bit of cleaning up because I think there was like somehow it was reading a sort of a blank, sort of an empty row in Excel. So just to prevent that, I decided to explicitly make it from row 2 to 32. But there are other ways I could clean up the data once I got it over here and saw that there was an extra one. an extra sort of non-number at the last entry. I could have cleaned that up otherwise, but I just decided not to bring it over in the first place. Okay, so let me shift and enter and bring that in. Okay, so now I have my temperatures, and I'm just going to use Mathematica to calculate some statistical quantities on this list of data of high temperatures in Philadelphia in August of 2015, because everybody wants to know that. All right, so the mean was the average or mean of those highs was 88. It was August. Quartiles is going to give me the first quartile, the median, and the third quartile. So shift enter that. Sort of, I don't know, the 0th and 4th quartile, if you will, are the min-max. So there is a min-max method in Wolfram. So that's going to give me the low and the high. And other statistical measures I like, and I'm going to compare these to what Excel gives in a minute. Standard deviation, sort of spelled all the way out. The skewness, so is the distribution like symmetric around the middle, or does it slant one way or the other? The kurtosis, sort of how does it compare to a normal distribution? You know, the tails in the normal distribution, are the tails longer or shorter? That's what the kurtosis will tell you. And then we can get some statistical plots. We can get a box and whisker plot. And this histogram. Now, there are probably ways to control these, but I'm just grabbing the quick sort of default versions. Then I'm going to do the same in Excel, grab, and I did that already. So here was the average, they call it average in Excel, and over here the mean, and we see that they agree. And the median was 88, and they agree there. There's some slight discrepancy in, I have this mislabeled. This was the third quartile, and this was the down here, the first quartile. Apologies. Okay, and we see that they're slightly different in their definitions here. They're off by a quarter. So the results was between 2 points, and Excel just seems to be going sort of probably halfway between 2 points, whereas over here in Wolfram, they seem to be taking sort of quarter of the way or 3/4 of the way between the points somehow. All right, so those definitions are slightly different. First and third quartile between Excel and Wolfram. The max and the min, they agree, 79 and 94. That's a fairly simple standard thing, so that they better agree there. Here's the standard deviation that agrees. Now Excel offers sort of population and a sample standard deviation. The sort of, if you just do the simplest, say standard deviation, it gives you the sample one, and that agrees with what's given over here in Wolfram. And the skewness is slightly different, so they must be working with slightly different definitions. I have not dug into these differences, I'm just pointing them out. And then the kurtosis, there's a bigger difference here. Now, there is in the definition of kurtosis, people will define, there'll be a major difference in the way people define kurtosis. And you can figure that out based on sort of what is the kurtosis based on someone's definition of a normal distribution. And looks like the Wolfram that it is 3. This is, you know, a reasonable, this is reasonably close to a normal distribution. We'll look at the histogram. We'll see that it's not a normal distribution, but not radically different from a normal distribution. So they're working with the definition of kurtosis where the normal distribution gives a 3, whereas in Excel, they work with the definition of what they call kurtosis is really the excess kurtosis, and that is defined to be 0 for the normal distribution. So the big difference between this and Excel is that this is the version that is going to be 3 for normal, and this is the version that's going to be 0 for normal. But we see that there's still more difference than that, because the difference between this and 0 and the difference between this and 3 are not the same. Okay. So there's more difference that one could sort of get into and look into there. I'm not going to do it. I'm just trying to keep it simple, but there we go. Okay, so this is the box and whisker chart that you can get out of Wolfram, and here's the sort of corresponding box and whisker from Excel. Now, this data had no outliers, so I'm not seeing how these might differ if there were outliers, but within the definition you have the min, the max, the first quartile, the third quartile, and somewhere in here it's usually a little clearer than that. I guess this line, this little knob here, that must be the median. And so that's the same here. That's the median, first quartile, third quartile, max, min. That's usually what's shown. And sometimes they will show a little dot. Sometimes in Excel, I can see a dot for the mean, but the mean and the median are quite close here. And then here is a histogram, and I just sort of went for the default uncontrolled histogram. In both cases, they're fairly similar looking, but they chose different bins, so they're not exactly the same. But in Excel, you can have some control over how many bins there are, or what's the width of bins. And again, there's probably similar control over Wolfram, but I'm just trying to keep it pretty simple for now. So that's what I wanted to show you. Reading in an Excel file, sheet, row, column, how to get a span of rows. I only wanted the one column, and that gave me a list. And then I had a bunch of statistical methods that Wolfram has defined that take in a list and give the statistical quantity of the numbers in that list. And we see that it's slightly different than Excel. So let me just make sure that we've got the same data. So 90, 90, 93, 93, 90, 90, 93, 93. So we're looking at the same data. And we saw that some of the measures, median and mean, were exactly the same. Quartiles were slightly off. Kurtosis and Skewness had a little bit more difference. But there are, variations in the definitions of these things, especially sort of, does one include the endpoints are not, and so there are subtleties in these definitions. Okay, thanks for your attention.